Good evening. Welcome to tonight's webinar. As we work through our webinar tonight, you may wish to participate in chats, and you can do that by joining the chat panel. If you don't have a chat panel showing on your screen, what you can do is hover over the bottom portion, and there should be a little chat bubble. If you hover over that, it gives you an opportunity to open a chat panel. Once you have that chat panel open, you have the option to choose all participants, and that's the way we'll be chatting out this evening. Everybody joining us, if you want to chat, choose all participants, not all panelists, not all attendees, all participants, and that will share your chat comments and questions with everybody joining in tonight. All right, so thank you for being here, and over to you, Connie.
Good evening. I'm so excited to see so many people joining us. My name is Connie Schrock, and I am past president of NCSM. Steve Victoria may be able to join us. He's having some technical difficulties, so we're going to head forward. And of course, Landy is online and ready to share some nice applications with the calculator as we proceed through this activity. Landy, you want to say hello?
Sure. Hello. Looking forward to it.
Okay, so we're excited about this evening. I want to start out a little bit by just sharing with you NCSM's mission statement. And what's really important about our mission is our bottom line is high quality mathematics teaching and learning every day for each and every learner, which includes students, teachers, and even administrators as we move forward with our projects and initiatives. Our vision is where we want to go. It's important to have a vision for what you're doing, and we try to let that vision motivate our movements and the choices that we make. So we wanted to share this with you. And again, our bold leadership, and that's been one thing we have to talk about, is mathematics education needs bold leaders to help us get where we want to go and to help students learn as much mathematics as we can. Now, overview of what we're going to do with the workshop. We're trying to share with you a facilitator's guide that we have that goes with the mathematical situations. And it looks like I see Steve, so in a minute he will be joining us to talk a little bit about this project. I was involved in it long before I became president of NCSM, and we are trying to share with you a way you can either use this with your students. If you're a math coach, you can use it with teachers. If you're a professional developer, you can use this. So we'll just move forward with this task. Steve, are you able to talk to us?
I was having some software issues, but I'm here. And the Situations Project started in the late 2000s, early teens. It was a project started by researchers at Penn State University and the University of Georgia. And it was a project that was based on what mathematics is useful for secondary mathematics teachers to know. And the situations came about from classroom observations. And all of us as teachers have had this kind of an experience where a student will ask a question, a great question, and we're not quite sure what the answer is or how to respond. And one of the things that they were interested in was developing a framework of mathematical understanding for secondary teaching. What should secondary mathematics teachers know in order to deal with these kinds of situations? We all know from a pedagogical viewpoint that these can sometimes be some of the best lessons that we teach. So the situations led to a mathematical framework that was focusing on mathematical proficiency, on the mathematical understanding for secondary teaching, as well as the context for teaching. And the situations really did come out of the classroom. They were common student questions. They were unusual teaching or tricky teaching situations, problems, surprising technology results, and Landy will probably make some comments about that, because some of the most interesting things that have happened in the classroom, at least from my perspective, have been reacting to what the technology has shown or has caused or has led to conversations. Extending ideas and representations also have led to these situations. So, Connie, and so we, I think it was 2012, some of us were invited to a conference at Penn State and the second conference at University of Georgia. And we were looking at the work that they had been doing with pre-service teachers. And those of us from NCSM thought that there was a real connection here to in-service teacher learning. And so we talked with Kathy Hyde and Pat Wilson, and went to the NCSM board, and we were able to come up with a collaborative situation to produce this facilitator's guidebook. So I think I'm going to continue.
So what is the situation? Steve talked about it a little bit, but there's a prompt that mathematicians, primarily this came from the situation book came from the mathematician side, where they were in classrooms watching students teach, or student teachers were coming back to the university and saying, this happened, I don't understand, what's the reason, why does it work? And so the situation book has a number of foci where it tells you many different reasons, and the reasons can be very simple or very complex, going clear up through abstract algebra. So what we did with the book is we created facilitators guides for 6 of the situations. Steve, you're going to talk about other things that led to these situations?
No, I think we could just go into this the specific situation, because
okay.
What we really need to focus on tonight is how to use the guidebook, what we have done with this book, and how this would help in professional learning. And Landy has a number of insights about how the technology can be used to do this. I will say, as a former department chair at a large suburban high school in the Chicago area, before the guidebook came out, I was using some of these situations in professional learning activities, and they were very favorably received by the teachers. And one of the things that we sometimes forget is that teachers like to do mathematics. And these situations in the guidebook gives us opportunities for teachers to do mathematics and reflect on that, and also to think about pedagogy.
The guidebook has the situation prompt completely. It has all of it that's included in the original book. It has the goals that introduce the mathematical ideas, and then it gives you facilitator notes, and I'm going to give you a few specifics on this particular situation as we proceed. Now, the 6 situations that are in the guidebook involve these 6 statements. The one we're going to explore this evening is mean and median, and if you're interested in circumscribing polygon, it was the previous webinar, which you can still access through recordings with Texas Instruments. So the mean and median the facilitator's notes begin with discussion topics. Are there misconceptions about the mean, about the median? What is the statistics? And then there's a launch that you can use for professional development, or you can use it with students. You can use it with college students. This is set up so there's a number of ways to use the book. In the beginning, this is a chart that the launch activity in the facilitator's guide asks to fill out before people look at the prompt, before they look at the student work, before they look at the particular situation. And Landy's going to go back to this just for a second when we launch to begin a little exploration on our own here tonight with the calculators. The facilitator's notes also continues with correct answers. It has things to challenge and explore. It mentions preparing your anticipated responses from your students or participants. When you're working with students, you would know more what to look at. Participants, if it's a professional development, are encouraged to generate questions they would ask the student to get to the reasoning and that they would have used for coming up with their solution. Now, this is situation 38. And it talks about two different displays of numbers. One is a box plot, one is a 5-number summary. And then it has the question, which of the distribution has the greater mean? Now, remember, we already know, we've already explored that neither one of these are going to actually show us the mean. So here are the displays that are provided in the situation. And I'm going to let you look at those for a second. We see the 5-number summary for data set 1 and the box and whiskers plot, or a box plot, depending on what you want to call it. It's called both. So I want you to think about this before we go into it. How would you approach this problem? Better yet, how do you think your students would approach the problem? How would your teachers approach it? So I'm going to go back to the graphs, and I want to hear from you in the chat box. How would you approach solving this particular question? And here are the box plot, the 5-number summary, and I want you to think about which of the distribution has the greater mean. How would your students begin to work on this? You can type in the box where it says all attendees if you have an idea what you're thinking about, how you would approach it. Okay, I don't know if I'm not seeing this. I've got a first answer and some more coming in. One person's talking about data set 1 being skewed. Thank you, Mary and Molly, for sharing with us. I'm going to give you just a few more seconds to think about this and share. Okay, we're going to move forward. I got another response on which one they think it would be, data set 2. So when one student solution is then shared and how that student came up with their solution, what they did is listed here. Okay. Now, there are some problems with this approach, and the facilitator's guide talks about how you would approach it. The foci also talk about these solutions a little bit. So before we begin, we're going to explore in just a minute, but I want to share with you a little bit more. The guide after the opening statement, it walks through the ways the mathematical foci are used. It includes possible activities to do with each of the foci, like creating posters, creating data that fit, using software. And it also has discussion questions that you might use with students, you might be able to use with teachers. So that's all included in the facilitator's guide. So foci 1, which was this now is written from the original situation book, talks about the skewness of the data and the relationship based on that. The second one given in this particular, and it said foci 1 through n, meaning each one of these situations has a different number of focus statements. This next one talks about a box plot display and the data values that are included in each quarter of the display. The third one talks about the exact values of two data sets are not known. The comparison can be sometimes made using the ranges of their possible values. So again, these foci in the book goes through a good explanation and discussion of these possible factors affecting it. And the last one talks about whether, the definite conclusion, the influences, and how this relates to the distributions. Now we're going to move over to the launch activity, and if I do this correctly, I'm going to toss this over to Landy, and he should be able to get us through the explorations with the calculator. So there you go, Landy. I'm looking at more of the answers in the box as Landy's getting ready to take over.
Wondering if we have audio. Do we have audio?
I can see a screen of Landy's. I just don't, he hasn't launched the PowerPoint yet. But
Okay.
I don't see.
No, I'm not hearing Landy.
I'm not either. But it doesn't look like he is muted. So I can go back to my screen and move forward a little bit. Landy, I'm not seeing a comment from him. So let me go back. Ruth, you want to toss it to me and I'll go back to my slides?
Yes, ma'am.
And then Landy, when you're there, let me know. So are you seeing my screen now?
It has come back to you, Miss Connie.
Thank you so much. So the launch activity is the one I mentioned previously, and so I'm going to move on to this box. And so I want you to think about the launch activity. Remember, you wouldn't have seen the prompt. But if a box plot, what do we know from certain for a box plot? What do we know about the 5-number summary? What can we approximate about the mean from these two different sources? What cannot be determined? What I did is I put numbers in here so that if you wanted to talk about something that went in one of these 6 areas, you could use the number instead of saying what you're doing. Oops, go back. And somehow during this, I lost. Can you still see it?
Connie, are you sharing your desktop?
Well, I was, but
Okay.
let's try one more time. Now can you see it? So here are the 6 numbers. And so I just wanted you to put in that chat box, what would you know for certain? What can you approximate? And I'm hoping Lindy will be ready with the calculator in just a minute. It says his mic has quit, and I don't know what to do about
We're working on it.
All right, perfect. So I'm looking in the chat box for some ideas on what do you know? What will your students think they know? There's some good answers a while ago. Okay, so Tara tells us, you know, the max and min, and that's for box 1. And so for certain, we know that from this box plot.
Can you hear me now?
Yes, I can. I'm ready to toss it to you.
Okay, we'll see what happens.
All right, so I'm
Okay.
going to do that.
Welcome back, Landy. Some reminders. If you'd like to join the chat, you can hover your cursor along the bottom until you see the chat bubble, and then if you activate the chat panel, it will be on the right. If you'd like to share questions or comments with everybody in the group, not just the panelists or the host, you would choose all participants from the drop-down panel. Thank you.
And there's some great comments on students might understand the median as the mean, and I see that a lot. Appreciate that comment. And you're on. I've tossed it to you. I'm not seeing your screen, Steve. Landy, you might need to share my screen.
I can't do this. Ruth, can you switch the presenters?
You got it. Oh, now it's back to me.
Huh?
It should. Somebody just switch it back to me. I'm going to switch it back to you. Now it's back to you. Sorry, folks. We're getting this worked out.
It's a well-oiled machine.
When I'm looking at this, I can't see the chat box. So before I switched over, I did notice that somebody had said that you can know the max and min for the from the let me back up here. Now, why is that not?
I see activity too.
Okay, but I was back here. Somebody had said that one of the things they could see that they knew for certain was the maximum and minimum. And I didn't see before I switched over whether that was for a box plot, for a 5-number summary, or for both. And I don't think I can see the chat window at the same time. Yeah, I can. Okay, hang on. Here we go. So you know the max and min, and that's the only answer I've gotten from anybody right now. So we're going to start with that. And let me kind of give you an idea of where I want us to go for the next few minutes. First of all, the activity that we're looking at probably is not necessarily best for somebody that's just seen a box whisker plot for the first time, although it might be interesting to mess around with it there. What I'd like us to do, though, going back to something that Steve said earlier, you were talking about getting answers and things like that. Tonight, what we're going to do is move from where the answer is obvious, although I'm not sure that that's possible in this situation, and maybe move you to a situation where we say, are we sure? And it's my intent that when we leave at the end of the session, that you don't have a definitive answer as to what the correct answer for this problem is. And we'll give you some homework, some playing around to do on your own. we're going to be using the TI-Nspire as a tool for what I'm going to do. And I like to think of the Nspire as sort of an electronic sandbox for playing around with things. I'll say a little bit of sort of how-to-ish kind of stuff about how to operate the Nspire, but this really isn't going to be a tutorial on how to use the Nspire software or handheld, but rather focusing more on how we might use that kind of a tool to explore the particular problem, the prompt that was given in the booklet. And the approach that I'd like to take is that of building a data set that somehow is related to the problem we're given. And there's at least a couple of different ways we can go about it. One is to try to build a data set that matches exactly the given 5-number summary and box plot. Another approach might be to try to build a data set that matches the student's response. So let's look at what the student's response is here. And what we're going to do is kind of explore some ways of approaching the problem that he was presented. So as I said, one thing we might could do would be to try to build the solution the student came up with and verify that it works or that it's a possibility. But I want to kind of go a slightly different way there. The other thing I'd like to say about this prompt before we really get into the playing around with it is that a webinar is probably not the best place to do this problem. What I would really like to have is a classroom full of kids or adults given the prompt and given 30 minutes to play around on their own with pencil and paper and software and things just to play with and see kind of what they can come up with. Unfortunately, I can't look over your shoulders while you play, and that would be very bad use of time for tonight. So you get to look over my shoulder, and I'll try to think out loud a little bit as some approaches we might try. So let me cut to the software. And as I said, we'll be using TI-Nspire as our tool, I guess. I'm going to be working with it in the computer view mode, but it works exactly the same way as with the handheld, and I'll make some comments in places where the menu choices are slightly different. So first thing you need to know is in the Nspire world, all data live in spreadsheets, lists and spreadsheets. So the first thing I have to do here is to add a list and spreadsheets page. And in addition to living here, it's got to be named. So I'm going to use the same names that were given in the 5-number summary, cleverly called 1 and 2. So someone mentioned in the chat window already that we know for sure the minimum and maximum values of the data set. So we could fill those in if we wanted to already. What I'm actually want to do is to build a data set for each of these two sets that exactly matches the 5-number summary and the box plot. So let me just try a quick and dirty, obvious sort of thing to do. So data set 1, I'm just going to type in the 5 numbers that were given. I mean, after all, a 5-number summary for 5 numbers ought to be the 5 numbers, right? So those are the 5 numbers. To look at data in the Nspire, you use a data and statistics page. So if I do that and add variable 1, which is what we just defined, there's the dot plot, exciting. And I want to change that to a box plot and see what we have. If we mouse over the screen, we see that the minimum value is 0. That's what we wanted. The median value is 102. That's what we wanted. The maximum value is 132. That's what we wanted. The lower quartile is 20. That's not what we wanted. The upper quartile is 120 and a half. That also is not what we wanted. So it turns out for the Nspire software, the 5-number summary of 5 numbers is not the 5 numbers. That is probably a surprise to most students when they start playing around with it. And the reason for that is that Nspire software does not consider the median be a member of the lower half of the data set. So if we go back and look up here at our raw data again, the median is 102, but it's not considered in the calculation of the lower quartile, which is defined as the median of the bottom half. So only 0 and 40 are included in that calculation. So the lower quartile is going to be 20 instead of 40. So if I wanted to make a data set that matches exactly, I've got to do something to fix that. There are several different approaches you can take. I'll leave one of them as homework. A related question is, what's the minimum number of points I could use in my data set to get the desired 5-number summary? That also is a homework problem I'll leave for you. I'm going to cheat here. If I know that I want 40 to be the middle of the bottom half of the data set, when I ignore 102 as the median, then what I need is some number between 40 and 102, so that 40 is the middle of the bottom 3 numbers. So I'm just going to add another number down here, the number between 40 and 102, put in 50. Same sort of logic. I need 109 to be the middle number between 102 and 132. So anything between 102 and 109 is okay. So we'll put in 104. And you can put any numbers you want here. So, just this much, filling in, how can you build a data set for students that are just learning about box-whisker plots and 5-number summaries. What we just did in a few minutes could take a lot longer with students if you let them sit down and play around and discover these ideas. So let's check and be sure that that actually works. 0 is still the minimum. Okay, lower quartile is 40, that's good. Upper quartile, the median 102, that's good. That's 109, that's what it should be, 132. So we were successful in building a data set that matches the first set of data. So I'm going to take the same approach to the second data set. I'm going to put in the 5-number summary first. And try not to make any spelling errors. And then I need 93 to be the middle number of the bottom set. So I need a number between 93 and 100. So let's put 95. And I need 115 to be the middle number between 128 and 100. So I need something between 100 and 115. So maybe 105. And then I look at the graph. But wait a minute. I've only got one box plot. I'd like to get both of them together. To do that on the computer, I'm going to do a right-click down here on the name of the first variable that I put in, and I get a dialog box that says Add Another Variable. If I'm on the handheld, instead of a right-click, I would use Control Menu to access that same command. I want to add variable 2, and since I'm already in box plots, it comes up as a box plot. And with luck, okay, the minimum is 76, that's good. 93, that's good. 100, yep. 115, yep. 128. So those are the 2 box plots that we started with in the given problem. But the question was about means and not about there's something called plot value, and here just means to plot a number in the data set. So what I want to see is the mean of data set 1 There it is. And likewise, I would like to see the mean of data set 2. So those are both drawn in as bars. Now, I saw a couple of flashes of chats go by, so let me go over and see if I can find out what's going on over there and see if I can answer anything there. Okay, somebody says talk louder. I will try to do that. The students should talk to list all data in order from least to greatest. That's certainly the way I would do it if I were going to try to compute the medians and quartiles by hand. And it would help, I suspect, students who were a little unsure of what I was doing in my playing around here, my choice of putting in these two numbers here. Remember, before I put those numbers in there, I didn't think I needed them. So my defense is I'm going to put them where there's empty space after I have them there, after I decide I need them. Again, I'll use as a problem, a good exercise is to go back in. I've got 7 points in each data set. Could I do it with fewer points? Could I do it with 6 points? Could I do it with 5? 5 didn't work, or the 5 that I picked didn't work. But you might try, can you do it with another 5, or can you do it with 6? But anyway, so this gives us a data set in each case that has the given box whisker plot. And if we look at them, sure enough, for the sets that I have, the mean of data set 1 is clearly below the mean of data set 2. But do they have to be that way? I mean, I just put in one data set for each of the two groups. Somebody else playing in the same sandbox could have picked different values. So one thing that I'm going to do here to help make the playing around a little bit more interesting, or to me interesting and more productive, is I'm going to split the window. And down here, I'm going to add another data and statistics page and plot the same two variables but as dot plots. So if we look at things, this number right here, the 40, is the lower quartile for the first data set. And this is the point that I added to make it be the lower quartile. Remember, I said I could put that point anywhere I wanted to between 40 and 102. So what if I took this point and decided, okay, I don't want it there. I can grab it and slide it. Now notice when I'm sliding it, the mean, which is visible up here as this vertical line, the mean's changing. So I can move the mean up closer to the mean of data set 2. And I can move this point, in fact, I can move this point all the way across the screen. But what happened when I did that? I can't move it forever. Well, I can, and it'll pull the mean with it. But at some point, the box plot says, you've gone too far. This isn't the same box plot anymore. So another question that students need to think about is, how far can you, how much fiddling around can I do and still keep the original box plot intact? And I can get all the way up to 102 if I wanted to, so I'm going to get a little bit close and stuff like that. The other point that I added in was the 104. So I could do the same thing with it. Now, one caution, in working with the Nspire, I was just moving this point here around. If I don't deselect it by clicking off here in space somewhere, if I select a new point to move, the old point remains selected and I'll end up moving both points. So I want to click away from that point, click on the new point, and now I can move it around. And again, it moves the median, it moves the mean. But again, if I move it too far, I start changing the box plot. So I can't go past the point at 109. So I can leave it here and the box plot's still intact. But By the same token, I could go up here and grab the added points, and I could move them down to move the mean of the second data set lower. And let's see, I think this was the point that I added down here. And I can't move it very far because I'm going to go down to 93. So I can do a little bit of damage to the mean up there. So what else could I do? Well, I could make the things that I'm moving around more massive. So think about, let me go back to the picture just for a second. Think about adding points, but you know, when I had a point that I could drag around to move the mean, I could drag it a pretty good ways and the mean would react. If I were to put points, an equal number of points in this interval, so the lowest quarter, the second quarter, the third quarter, fourth quarter, if I put an equal number of points in each one of those intervals, the box plot wouldn't change. Again, that's something that may or may not be obvious either to students or teachers that have not played around with box plots. So again, this is sandbox time. What happens if you throw points in? So just for fun, I'm going to throw in 5 points in each interval. Remember, these define the intervals that we're talking about. So I'm going to put 5 points between 0 and 40. I'm going to put them all the same so I can grab them at the same time easier. So I'm going to put in 5 tens and hope I can count to 5. I'm going to put in 5 numbers between 40 and 102. So I'll go back to 50 again. I need 5 numbers between 102 and 109. So let's say 105. One, two, three, four. I need one more. And I need 5 numbers between 109 and 132. So let's say 115. So again, the numbers that I put in each interval don't have to be the same. I didn't have to pick 5 numbers that were the same. I didn't have to pick 5 numbers. I just need to have the same number of numbers in each block that I'm messing around with. And these are all things that students ought to have time to play around with. That is, what happens if you add 1 more point within each interval? What happens if you add 2 more points within each interval? What can you do with those points? Where do they need to be? All of those are things that are explorable. So let's verify, first of all, that I haven't messed up with my box plots. I still got 0, 40, the median's way over here, 102, 109, 132. So we're still good there. So now I can grab these 5 points, watch the mean. Right now the mean of data set 1 is 73 and a bit. If I grab these points, I can move them all the way up to that next dot. I can get them as close to 40 as I can. That's about as close as I feel comfortable with. And in the process, I've moved the mean from 73-ish up to 79-ish. I can do the same thing with this stack of dots. So now the mean goes from 79. I can move it again, and I get to go all the way up to 102, or as close as I feel comfortable getting to 102. And now I've moved the mean all the way up to 88. We can move these 5 points. They don't have as much space to run because I can only move up to 109. We have the mean up to almost 89. And I can take these 5 points and I can slide them up and take them all the way up as close to 132 as I feel comfortable. We've got the mean all the way from started at 73. I've got it up to about 92 now. Well, you can think about other things that you could do at this stage. Why not play the same game with data set 2 and move its mean down to meet this one? Why 5 points? Got a lot of time, but in 100 points. So what you see is that there's a lot of playing around here that students could do, and teachers can do. And in a sense, what I've just done here by adding in extra points and all points toward a way that you might come up with a provable result for this particular problem if you wanted to. Sort of a limiting case of throwing in more points and seeing what happens. But the real point here is that as you, if you have an environment like Nspire that allows you to move points around easily, then you can do a lot of thinking, fiddling that you can't do as easily on static pencil and paper. It's hard to build example data sets and play with them if what you've got to do is a lot of by-hand calculations and erasing your dots and moving them around on a piece of paper. So to go back, let me go back to the slideshow for a minute and look at the foci that Connie mentioned earlier. The first response that we had on the chat earlier mentioned the skewness of the data. And I think that's probably what most students who have played around with data sets would take. And that would be what I would expect from my students would be, oh, look, skewness is going to have a relationship on the mean. It's not going to affect the median as much. And so data set 2 ought to have a mean that's higher than data set 1. The problem is that what focus 2 is all about, and what we've really exploited in our fiddling, is that when you see a box plot, you really don't see the distribution. So we can't look at a box plot that looks skewed and say for sure it is skewed. It may not be that inside the whiskers or box itself that the data really are distributed in a skewed sort of way. And I showed an extreme view of that when I threw in the 5 points in each interval. So focus 3, the main point here is that when you don't actually know the data, we weren't given the data, we were just given the summary. If you don't really know the data, then at least on the surface you can't be sure about how everything's going to come out. So comparing the means may not be something that's actually possible, even though our first glance says, oh yeah, it's obvious what is going to happen. And the idea of adding points in sort of gets at this thing in Focus 4 about the size of the data set. As I add more mass within each interval, I can have more influence on the value of the mean. And as I say, that points towards something we could sort of do as a thought experiment to come up with a limiting case argument for what might be an answer. And we may end up proving that there's not a definitive answer, or we may be able to prove that there is one. Again, I'll leave that as an exercise to the reader, as they say. I want to mention a website that has a number of different statistics explorations, but 2 that are directly related to what we've been doing this evening. Is the box plots introduction activity and the multiple box plots activity, both of which live at the TI website under a project called Statistics Inspired. And there's tons of resources there on a variety of different areas of statistics, but these 2 in particular are related to box plots and their interpretation, and would be good to use for students who are just getting started with understanding how a box plot works. At that stage, I'm going to stop before I say more than I know and open it up for questions and for Connie and Steve.
Ruth put the tiny URL in the chat box, and of course TI will have a recording of this webinar, so you'll be able to go back and access those tools. Do you have any questions for us at this point? I'm kind of looking at the chat box.
And Connie, do you want the screen back?
No, I'm
okay.
good. I'm just going to let you run it.
Okay, that's fine.
Give a couple more seconds if people have questions. question. So I have a couple, you might go to the next slide. I have a couple events I just wanted to remind you of. And one is that this summer we are approaching our early registration deadline for our Summer Leadership Academy. The theme is empowering coaches and teacher leaders as agents of change for all learners, and it's in Madison, Wisconsin. And again, you can go to mathedleadership.org and find how to register and more details on this event. I just want to invite all of you to join us. If you are in that role, if you're a classroom leader, it is going to be a great event. We have 3 or 4 books to share with you at that event. I hope you've enjoyed this webinar. There's so much that technology allows us to do, the exploration, and it's important for students to do that trial and error, for teachers to do the trial and error, to change the way they teach so that they grow. The last slide we have for you includes our annual meeting, which this year is going to be in Chicago. It also has a picture of the Facilitator's Guidebook. And we appreciate you attending. Thank you for joining us this evening.
Absolutely. I hope it was worthwhile in all respects.
Appreciate your time. Good night.
Good night.